Well, in this video, we will be looking at restricting the domain and range of a parabola. As you have seen that if a function is many to one function, many x values to a single y value, the inverse will be one to many relation, meaning that many y values to a single x value. I'll repeat. As you have seen that if a function is many to one function, it means that many x values to a single y value, and the inverse will be one to many relation, meaning that many y values to a single x value. Well, guys, what does that mean? It means that the inverse of any many to one function will never be a function. However, the domain of many to one function can be restricted in the range so that its inverse is a function. So remember, I want you to note this in your notebook. Only the inverse of one to one function itself is a function. Only the inverse of one to one function is itself a function, not many to one. I hope you have noted that. Well, guys, if you're new to this channel, what are you waiting for? Do the needful, do the right thing, subscribe, like the video. Remember, guys, it's free of charge. It's free of charge. Let's grow the community. So this week I'll be posting more videos for us to practice, guys, right? So well, today we'll look at restricting the domain and range. Without wasting time, let's get to it. Consider you're given, let's say, this function f of x is equals to x squared, and there is this graph of a straight line which is y is equals to x. Let's consider sketching them. We'll understand it better with a sketch. Right, so this is the y-axis and this is the x-axis, right? So such parabola does not have what do we call this, does not have an x-intercept, but you can find other points using the table, right? So since this parabola it's a smiling curve, it's positive, so it will be a smiling curve. So we will have something like this, right, guys? We will have something like this, right? So let's consider maybe this is 0, -1, 0, -1. Let's say this is -1, -1 and 1. Probably we will have this. Let's say we have -1 and 1, right? Let's consider here we have we also have 1 is to 1. We'll also have 1 is to 1. Then okay, then the inverse, we know the inverse, guys. If you have -1 is to 1, the inverse will be, you swap, right? So where there is -1, you replace it by positive, and where there's negative, you replace it. So we now have 1 and -1. So in this case, this will be 1 and -1, meaning that your point will be here, right? And the other one, which is 1 is to 1, will remain here, and this one, 0 and 0, will also be here as well, right? So after that, you can join the points. You have something like this. You will also have something like this. Sorry for my rough hand sketching, but this is how it should be. So what about y is equals to x? Y is equals to x will pass through this, right? We'll have a straight line there. Y is equals to x, right? We'll have y is equals to x, right? So we've already drawn the inverse of this, right? The inverse of this. So what I want you to remember, Remember that this is not a function, so we need to restrict it. As you've seen in our previous video, guys, the inverse of f is not a function of this f is not a function. So we need to, in order for the inverse, guys, to be a function, this is what I want you to note. The domain of the original function has to be restricted. No? The domain of this function has to be restricted so that one arm of the parabola is cut off. I'll repeat, the domain of the original function has to be restricted so that one arm of the parabola is cut off. How do we do this? In order to do this, guys, you have to restrict the domain from the turning point, meaning here from the turning point. The turning point is here from the turning point. Therefore, there are two different restrictions that can be placed, guys. We will have two restrictions. This is how I see it. Therefore, we are going to have two different restrictions that can be placed on the domain so that the inverse is a function. What are those restrictions? You will have to say x is lesser or equal to 0, or x is greater than 0. Or this can be written as x is an element, negative infinity and 0. Or we can, x is an element, 0 and positive infinity. Okay, then yes, this is how you're going, the restriction will be, this is how you're going to have it. So which arm can we cut? If we cut off this piece, if we cut off this arm, guys, when you cut off this, can you see what we are left with? Let me use my hand here. Can you see we are left with what? When you take out this top part and this arm, we are going to have something like this. Something like this. Remember the other one? Okay, and we also have, we have to follow, remember it's from the 0, so the other one will be, sorry for my, yes, this is how it should be. Remember, there must be a straight line, that's the other straight line, y is equal to x, which must passes here. So you can use different color to make everything to be nice. Remember, here it was all to make it nice, right? So this is the inverse graph after we have cut off this arm and this arm, right? So if we take out this part, this arm, what are we left with? You can see we'll be left with this top part and this bottom part, meaning that we are going to have something. Let's consider this. We're going to have something like this and something like this. So which is the graph of the inverse. Then passes with a straight line there. So as we can see, this is how you make it a one-to-one function. Then you can use a vertical line test. Using a vertical line test, we can see it's one-to-one function. Using a vertical line test, you can use a ruler there to check whether it's one-to-one. So it's one-to-one, then we can say that it's what do we call this? It's a function. It's a function. Another thing that I want you to note, so when you write the domain here, remember your domain for this one will be x is greater than 0. X is greater or equal to 0 because we're on the positive side here. So the range here, it will be or y is greater or equal to, or you can use the other one, y is an element 0 to infinity, or the other one for x 0 to infinity, right? So what about the domain for this one? The domain for this one will be x it's less than or equal to 0. Where x is less than or is equal to 0, it goes here. It goes here down. So for this part, right, so the range, but the range will be y is greater than 0. Yes, the x values decreases, the y values increases. So yes, we are going to have x is less than or equal to 0, y is greater or equal to 0. For the other path, remember we're making this. For the other part, we can say x, the domain can be x is greater or equal to 0, or y is less than or equal to 0. So that's how it goes with restricting the domain and range, guys. I hope I've made it clear. Remember, you will use a vertical line test, so you must cut some arms for you to restrict the domain. I hope that put some light on you. So tomorrow we will have an activity. We'll have an activity about that, guys. Restricting the domain and range of a parabola, grade 12. So for those of you who are doing grade 11, starting from Wednesday, guys, Wednesday we are working with trigonometry. We are revising trigonometry. So tune for in, guys. Let's subscribe, like, comment. That give us that give us courage to make more videos and to learn. As we all know, guys, that learning is infinity. Right, thank you guys, for those of you who have subscribed. We are growing, we're reaching 1.1 soon. Subscribers, we really appreciate. Yes, and also, guys, yeah, let's grow, wishing you a prosperous year this year, 2025. May you ace it. May you ace this term 1. May you also ace term 2. I wish you all the best, guys. Share the video, subscribe. It's free of charge. You don't have to pay anything. And remember, we love you.